Hey everyone, in this video we are going to take a look at a very specific scenario that I'm sure all of you must have encountered while working with DAX, and that is of expanded table. And I'm sure expanded tables must have messed up your calculation at least once in case if you have used them without knowing how they are actually working in your calculation. And the topic of this video is just the expanded table, and through this video we are going to understand how they are actually going to impact your calculations. And before we move ahead, a quick introduction of the data model. So we are using the Contoso database, which contains the sales table, customers table, dates table, products, product subcategory, and the category. So on the left hand side, we have one to many, and then one to many relationship between category, subcategory, products, and the sales table. Whereas we also have another one to many relationship between customers and sales, as well as dates and the sales. So let's say we want to create a report and we have the category column from the category table, as well as a measure which is actually computing how many customers are there in the customers table. And what we want to do is slice the number for the customers table by the category. So you can see that if I put a filter on the category table, that filter will go to the subcategory table, then it will reach the products table, and finally it will reach and filter the sales table. But that filter will not be able to filter the customers table unless we turn on the bidirectional filtering. But that is not something we are going to do in this video. So let's go back to the report and let's say we want to fix this calculation. So how can we do that? So we can wrap this calculation inside a calculate, and here we can write that sales, and that's it. And if I close that and press enter, you can see that this time we are not repeating the same number for each cell of that visual. And in case if we want to verify if that calculation is correct or not, what we can do is bring the customer key from the sales table, and what we can do is aggregate that. So let's do a count distinct over that, and you can see that we are returning the same value for each row. So how is that? Just by using the sales table inside calculate, we were able to fix the calculation, and that is what we are going to discuss. So before even talking about expanded tables, we are going to take a look at another couple of examples so that once we end this video, we are able to understand how everything is working. So let's move to the next page, and let's say we want to identify the sales amount for the red products in either 2007, 2008 or 2009, depending upon the selection over the slicer. I also want to go back 1 year. So in case if I've selected 2009, I want to report the red sales for 2008. If I select 2008, I want to report the red sales for 2007. So let's create a measure and let's try to identify if the calculation that we are going to write is going to work or not. So we can create a new measure and we can name it as red sales. So we are going to write that calculate total sales, and let me just show you the definition of the total sales so that there is no confusion. And let's find our total sales measure, and you can see that it is basically a sum x over the sales table, and in the row context we are going to multiply the quantity by the net price. So let's get rid of that and let's go back to the measure. And what we are going to do is first we are going to write that filter the sales table where the related products color is equal to red. So if I close that, this is a valid calculation, just know that. And if I write same period last year over the dates, date column, and if I close that and press enter, and let's bring that calculation in a card visual. So let's drag and drop it here, and you can see that we get a blank. So if I select 2009, I should be reporting 24,343, and in case if I select 2008, I should be reporting 51947. So what is happening here? Let's try to rewrite that calculation once again and see if we are able to get the result or not. So I'm going to create a new measure and let's name it as red sales 2. So this will be a calculate over the total sales, and we are going to write that filter the sales table where the related products color is equal to red. And what we are going to do is we are going to close this calculate and we are going to initiate another calculate over this calculate. So let's indent everything. And this time we are going to write that same period last year, dates, date. Let's close this calculate. And if I press enter, and let's bring that as well in a matrix, and you can see that we get the result. So if I select 2008, I get 5951949. If I select 2009, I'm getting 24,000. And if I select 2010, I get 39,724. So you can see that this calculation is working. And there is another way of writing that calculation. So we can take a look at it as well, so that when we are going to close this video, we are able to understand how that one is also working. So we can write that red sales 3, and this one will be a calculate. We are going to compute the total sales, and we are going to simply write that products color is equal to red, and that same period last year, dates, date. Let's close calculate, and let's minimize that. If I drag that measure into that card, you can see that these two are returning some value which is actually correct. So if I select 2009, they are returning correct result. If I select 2008, they are returning the correct value. But something is wrong with the first calculation, because of which we are actually returning a blank and not the correct value. And let's see how we can understand what is actually happening here. So now that we have seen a couple of calculation on how the expanded tables are messing up our calculation, let's understand a little bit of theory about the expanded tables. So what is an expanded table? Well, before understanding what is an expanded table, you need to understand that all of the tables that we have on the screen can also be called as base table. So the customers table on its own is a base table. The dates table on its own is a base table, as well as the sales table, products, product subcategory. All these tables can be called as a base table. So when does these tables become an expanded table? So once you create a many-to-one relationship between one table and the another table, the base table actually becomes the expanded table. So what is the base table in that scenario? The table that is on the many side of the relationship. So in case of the relationship between the sales table and the customers table, the customer table is also a base table and the sales table is also a base table. But when we talk about the expanded table, the sales table expands to the customers table, the sales table expands to the products table, because there is a many-to-one relationship between all the tables and the sales table. So when we talk about the products table, products on its own is a base table. But since there is a many-to-one relationship between the products table and the subcategory table, then we can say that the products table expands to the subcategory table, as well as subcategory table expands to the product category. But after the product category table, there is no table which is having a many-to-one relationship. The product category doesn't expand to anything. So why am I talking about expansion, and why all this thing makes sense in our scenario? The thing is, when we talk about the sales table, logically behind the scene, you can imagine that sales table will expand to the customers table, and expansion basically means that sales table will have access to all the columns of the customers table. Similarly, sales table will also expand to the product category table, because there is a many-to-one relationship, and there is another many-to-one relationship between the products table and the subcategory, as well as the product subcategory and the category. So how can we verify that a table expansion is actually happening? Well, you can use the related keyword on any table, and in case if you are able to access the column from the one side, then you will be able to know that a table expansion can happen in case if you are referring that base table. So let's say we go to the sales table, and we can create a new calculated column here. So we can click on the new column, and let's say I want to retrieve the product color from the products table for this particular product key. So what we can write is related, and if I open that, related will only give the list of columns in the IntelliSense that can actually be expanded from the sales table. So you can see that the customer table and the sales table has a many-to-one relationship. That's why we get the list of customer table columns. Then we also have the columns of the date table. Then we also have the product subcategory, product category. So let's say I select products color, and if I close that and press enter, you can see that I'm able to create a new column in the sales table with the help of the related keyword. So basically, related only gives you access to the columns of the table to which the base table can actually expand. So if we change the nature of that relationship from many to one to many relationship, that calculation should stop working. So let's change the nature of that relationship to a many to many. And if I click on OK, you can see that we get a warning symbol. And let's go back to the sales table, and you can see that we are getting an error that the column products color either doesn't exist or doesn't have a relationship to any table in the current context. The warning that you get is not very user friendly. Basically, it means that the sales table cannot expand to the products table, because of which you are not able to actually access only one single value for that particular row item that we have inside the sales table. And since we are using the many to many relationship, the table expansion doesn't happen and the related doesn't work. So let's go back to the diagram view and fix this calculation. So let's change the nature of the relationship to many to one. And you should also know that the table expansion will not also happen in case if you deactivate that relationship. So if I click on OK, you can see that we still get the warning symbol, because this time the sales table cannot expand to the products table. So let's activate that relationship so that we can get the calculated column back once again. And you can see that the calculation just starts working. So before we start looking at the calculations that we have already done in the report, let's reiterate the definition of the expanded table. So in case if you have a data model where you have a star schema or the snowflake schema, then in case of star schema, the fact table will actually expand to all the table that you have in the data model in case if there is a many to one relationship between the dimensions and the fact table. And in case if you have a snowflake schema, then the longer path that we have for the, let's say, product subcategory and the category, they all will expand to the base tables, which is in case is products for the product subcategory and category, product subcategory for the product category. And for all these tables, the sales is the base table. So sales will expand to all these three tables as well as the customers and the dates table. So you can basically imagine that it is performing a left outer join where you put the sales table on the left hand side, and you basically start writing a SQL code that select star from the sales table, left join customer key on the sales table, customer key, left join date table on the sales table, order date, left join products table on the sales table, product key, whereas left join product category key on the subcategory key on the products table, and then back to the sales table. So by thinking in the terms of expanded table, you can basically imagine that behind the scene, logically, sales table will have all the columns in one single table. Now, table expansion is just a logical concept. So it is not something that behind the scene, it is going to expand and increase the size of your data model. The expanded table only comes into the picture when you're referring to a table which is the base table and also has a many to one relationship to further other tables. So that was a lot of boring theory about the expanded tables, and I'm pretty sure I have bored you a lot. And now what we can do is try to fix those calculations that we have already done in the report view. So let's go back and let's first of all take a look at this one. So we are slicing by the category column from the products category table, and we are trying to count how many customers there are. So what are we actually doing here? We are using the expanded sales table as a reference here. So once the filter context contain a value from the category table, that filter will reach the sales table from the subcategory products and directly to the sales. Since sales is an expanded table and we are using that reference inside the calculate, sales will contain the column of the customers table as well. So when we are applying a filter over the sales table, indirectly we are also filtering the customers table as well. So you can simply think of the left outer join that we have already talked about. And now let's take a look at the red sales calculation and try to understand what is actually happening in that. So let's go back. And let's first start with the blank calculation. So if I select that measure, you can see that we are writing a nested code. So we have the calculate total sales, filter over the sales and the same period last year. So what we can do is try to break that calculation step by step. So first we need to identify what is the external filter context that exists out of the calculate. What is that? We have a selection over the slicer. So we are saying that the calendar year number should be 2008 and the calendar year can directly filter the sales table. So that is clear. So let's select that. Then in that filter context, the sales table will be evaluated. So the sales table will only contain the row for the year where the calendar year number is 2008. That is fine as well. Then in the row context, we are checking that the product color should be red. So let me just write here that the year is equal to 2008. So here we are saying that the sales table is filtered for the year 2008, and we also want that sales table should be further filtered for products color equal to red. So we have two filters here, one that is created by the filter context and one that is getting created by the filter. So that part is clear. So we are evaluating sales in 2008 and we are returning only those rows of the sales table where the product's color is red. Then we have the same period last year. What is same period last year doing? Same period last year is getting evaluated in the filter context where the year is 2008. So same period last year is going to receive a list of date in 2008 and it is going to shift those dates in 2008 to 2007. So the table that is going to be returned by same period last year will only contain the dates for 2007. Now, once these two operations are complete and calculate prepares the filter context and applies these two filters into the filter context, what is going to happen? So let's write here that this will contain year is equal to 2008 as well as products color is equal to red. And the result of the same period last year will be 2007. So when we apply that filter into the filter context, we have a filter of the product color is equal to red, but on the year column, we have a filter over 2007 as well as 2008. So in this data model, there are no single transaction that exist in two different years. So when Calculate tries to merge these two filters in an AND condition, it will say that the year should be 2008 as well as 2007 and then the product color should be red. And since there is no row in the sales table where year is 2007 and 8, we are not able to evaluate even one row in the sales table, because of which the total sales measure is evaluated for nothing and it simply returns a blank value. Now for the sake of explanation and to make it easier to understand, I actually said that the year will be 2008 and the product's color will be red. That is going to be returned by the filter over the sales table. But that is not completely true. The end result or the filter context that is going to be prepared for this argument will contain all the columns of the sales table and all the columns of all the tables to which the sales table can be expanded to. So if you start thinking in terms of the expanded table, you can understand that once the sales table is filtered for the year is equal to 2008, how can it actually return year is equal to 2008? That is because of the concept of expanded table. So when we are filtering the sales table with the filter context where the year is 2008, we are also indirectly filtering the dates table as well, because we are applying that filter over the sales table. Sales table has a relationship of many to one to the dates table. So let's say we create a new calculation where we want to identify how many rows are there in the dates table that are there for the related dates calendar year is equal to 2008. And that is going to help understand the concept that I'm trying to explain. So we are going to write that calculate count rows of the dates table, and we are going to write that filter all the sales table, and we are going to say that related dates calendar year number should be equal to 2008. And you can see that inside calculate, I have not referenced any filter over the dates table. So you can see that we are simply checking that dates calendar year number should be 2008. And ideally, this filter should not be able to filter the dates table. And you can see that we are using the all table. So all is actually going to ignore the filter context that is going to come from the slicer. So if we confirm this measure, and let's create a new card for that. And you can see that we are returning 348 rows. So how is that possible that from a table of the dates table where it has 2500 rows, we are only returning 348 rows? And that is what I wanted to explain to you. In case if you are going to use expanded table, you are going to indirectly filter the other table as well, which are connected through a many to one relationship. So you can see that we do not have any filter over the calendar year, but still we are actually limiting the number of rows that are visible for the dimension table that we have on the one side. And let's go back to the calculation. So by now you can actually understand that when we are returning the sales table, we are also returning a filtered version of the dates table, filtered version of the customers table, products table, category, product subcategory. Now let's move on to the next calculation, which is red sales 2. So what is happening in this one? So we are going to start with the outer calculate, because in any scenario, in case if you're nesting calculate, then the outer calculate prepares the filter context for the inner calculate. So you can see that on the slicer, we have the calendar year is equal to 2008. So let's write here that the same period last year will be evaluated in the year is equal to 2008. When the same period last year gets the date for 2008, it is going to shift those dates in 2007. So that will be the filter context for the inner calculate. So this calculate will be evaluated where the year is 2007, where the dates are actually returned for 2007. This filter context will filter the sales table. So sales table will only be limited for the rows where the year is 2007. So let's write that year is equal to 2007 and let's make it a comment. Once we have the rows for 2007, we are going to check that related products color is equal to red. So how is that this calculation is actually working? So unlike the first calculation, we are not returning two different years, and those two different years are not getting applied on the filter context. So the table returned by the filter function will contain all the rows of the sales table where the dates calendar year number is 2007. Once this filter is applied to the filter context, we are going to get the sales amount for year is equal to 2007 as well as the product color is equal to red. Whereas in the first calculation, we were returning the year is equal to 2008 and same period last year was returning the year is equal to 2007. But this time we have prepared the filter context for the sales table with the help of same period last year by nesting the calculate one inside another, because of which we are only returning the rows from the filter function where the year is 2007 as well as the color is red. And finally, we have the calculation where we have a very simple calculate, and you can see that we only have two statements, products color is equal to red and then same period last year dates date. So what will happen here? Same period last year will be evaluated in a filter context which contains the dates for 2008. Same period last year will return dates for 2007. So this filter will contain only the dates of 2007. Products color will apply a filter context of red over the products table, which will in turn filter the sales table and only contain the rows for the red products. So when these two values are applied in the filter context, they are going to filter the sales table and not the expanded sales table. So you can see that nowhere in the code we have referenced the expanded sales table. And this is the ideal scenario that you should ideally use in case if you're working with a scenario where you're trying to reference the expanded table. The reason being that when you use expanded table, the calculations become really convoluted. You are not able to identify why your calculations are returning incorrect result. And you can also imagine that in case if you do not understand the concept of expanded table, you might develop this particular code as a model measure and then deploy it in the production, and other users might start creating another measures over this measure, and they might not be able to figure out why the calculations are not working because they do not simply possess that level of understanding about the DAX language. So in case if you're working with the DAX language, always try to put the filter over the single column, because when you use a single column, the concept of expanded tables is not applied. So when you use products color is equal to red, the filter reaches the sales table, but that filter cannot reach to the customers table because you are not using the expanded sales table. And similarly, you can also write something like sales quantity, let's say greater than 2, maybe 2. So let's press enter. And this should return some result, But you can see that we are not returning a blank because when you use a single column, you do not refer to the concept of expanded table. You are simply applying a basic filter over the sales table, which do not propagate to the customers tables or the dates table or the products table following a many to one relationship. So before wrapping up, what we are going to do is we are going to take a help of DAX Studio so that we can actually verify the claims of this particular code where I said that the year is 2008 as well as 2007. So let's go to the view tab, click on performance analyzer. We can start the recording. Let's refresh that visual and let's make sure that we are selecting the blank card. So let's check that we can copy this code, and from the external tools, we are going to launch DAX Studio. And let's paste that code. Let's format it as well. And if I press F5, you can see that in the results pane, I simply get a blank. And what we need to do is turn on the server timings so that we can understand what are the queries that are generated behind the scene. So let's go to the server timings tab. And if I press F5, let's expand everything. So the first query that is getting executed against the storage engine is for retrieving the dates date column from the dates table. Then we have the dates date from the dates table where the calendar year number is 2008. So this one should be for the slicer, and I think the first one is for computing the same period last year. Let's go to the third query, and this is the most important one because you can see that here we are saying that select sales quantity times sales net price. So we have that expression. Then we are saying that select the sum of that expression, which is the total sales from the sales table. And we are saying that sales order date should be equal to dates date. So we are performing a join on the sales table, which is on the left hand side. And then we are also performing a join on the product key from the products table. And in the where clause, there is something that we need to pay attention to. So first, let's see that here it says dates calendar year number should be equal to 2008 and the product color should be red. Then we have another condition which says that dates date in a range of date. So what are these dates? So ideally, I would think that these dates must belong to the 2008. But let's say we copy this date and we go to Excel and let's paste that date here, and I'm going to change that formatting to a short date. And you can see that that date actually belongs to 2007 and not 2008. And let's try a couple of dates. So let's select this one and let's go to Excel and let's paste here. Let's change the formatting once again. And you can see that first we got the 20th of January, then we are getting 26th of April. So that helps in clearing the confusion why we were actually returning a blank value, because we are saying that the dates calendar year should be 2008 and we are applying an AND condition that the dates date should be in 2007, and this 2007 is basically because of the same period last year. So let's change the measure reference to red sales 2, and if I execute the code, you can see that first we get the dates date from the dates table. Then we are filtering the dates column for the calendar year number to be equal to 2008. And in the third query, we are saying that the select sales amount where the sales table is on the left hand side. Then there is a join between the order date, dates date, product key, product key. In the where clause, we are saying that product color should be red, and we are saying that the dates date should be in these dates. So if I select this date and let's say go back to Excel, and if I paste it here, and let's select the short date format, and you can see that we are returning 2007. So this time we are able to return a result because we are not applying a filter on the where clause where we are saying that dates calendar year number should be equal to 2008. So hopefully this video was helpful in understanding what are expanded table and how they can actually mess up your calculation. Now expanded tables are not actually really intuitive, and neither they are actually easy to understand or easy to explain, but I have tried my level best, and in case if you have any questions, just let me know in the comment section and I will see you in the next video.
Hey everyone, thanks for tuning in to Enterprise DNA TV. If you enjoyed the content covered in this particular tutorial, please throw the video a like. It really helps us and we really appreciate it. Also, don't forget to subscribe to the Enterprise DNA TV channel. We have a huge amount of content coming out all the time from myself and a range of content creators, all dedicated to improving the way that you use Power BI and the Power Platform. Lastly, check out Enterprise DNA's website. Plenty of resources and further learning that you can access very easily. All the best. Take care.